today's problem from polar equation, and the problem is show that the point of intersection of the straight line, two straight lines are given, r into cos of theta minus alpha, this is equal to p, and the second line is r into cos of theta minus beta, this is equal to p, is given by this. It is given, we have to see that the point of intersection of two straight lines is given by this and this. Okay, and now we first write two straight line. This is r cos of theta minus alpha, this is equal to p, this is 1, and r into cos of theta minus beta, this is equal to p, this is 2. Okay, now for intersection of 1 and 2, we must have two value of r from these two equations are equal. So we get, this is p by cos theta minus alpha, this is equal to p by this is cos theta minus beta. Okay, and this gives cos of theta minus alpha, this is equal to cos of theta minus beta, and we get from this relation, this is theta minus alpha, this is equal to plus minus theta minus beta. Okay, because we know that cos theta, this is equal to cos phi, imply theta, this is equal to plus minus phi. Now if we take plus sign, then we see that theta from both sides are cancelled out, then we cannot find the value of theta, so we take the negative sign. Now we write here taking negative sign, we get the relation as theta minus alpha, this is equal to minus of theta minus beta, so we get 2 theta, this is equal to alpha plus beta, that is theta, this is equal to alpha plus beta by 2. We get the value of theta at the point of intersection. Now we put the value of theta in any one of 1 or 2. We put here in 1, we get r, this is equal to p by cos of alpha plus beta by 2 minus alpha, that is p by cos of alpha minus beta by 2. Okay, and this gives p sec alpha minus beta by 2, and point of intersection is given by point of intersection of 1 and 2 is given by r theta, this is given by r is this is p sec alpha minus beta by 2, and theta is given by alpha plus beta by 2. Very easy problem, and this is the proof. Okay, very easy problem of polar equation. Thank you for watching.